Hi there, this is video 810, and we're looking at the scale factor in 3D objects. And we're going to look specifically at the volume and surface area. So I've got this handy dandy, well, technically it's a rectangular prism, but basically it's a box. And you're all familiar with volume. Volume is length times width times height. So I said this is my length, this is my width, and this is my height. But truth be told, it completely doesn't matter because you're multiplying. So the answer is going to be saying whatever order you do it in. Okay. And surface area is, if you took this box and cut it apart and flattened it out, how much cardboard would it take? So we are going to calculate the surface area and the volume. And I know you're really smart. You're going, it looks like she already did that. Yeah. And I made a mistake. And then I got off. Confession time. I was just having a bad day and I freaked out, so I just erased everything and I couldn't fix it on camera. So I'm going to try it again. So I saved a tree by not reprinting this for us. All right, so our length is 5, our width is 1, and our height is 3. So the handy dandy textbook gave us the formula for surface area. And it's twice. Now the 2 comes from, okay, so length times width is the top part here. And that 2 out front is because there's a top and a bottom. So length times width, so it's going to be 5 times 1 plus, then we go length times height. So the length times the height, so that's like the front, and there's a back. So that's 5 times 3. Oops. Let's make the same format. Plus, then we need the 2 sides here of width times height. So it's 1 by height was 3. And before I go any further, I just want to make sure 5 and 1, 5 and 3. So basically, it's all the different pairings that you can get of 2 of these. So 5 and 1, 5 and 3, and then 1 and 3. If none of the numbers are the same here, then somewhere in here you have 2 sets that match. That'd be a bad thing. So surface area is equal to 2. 5 times 1 is 5, plus 5 times 3 is 15, plus 1 times 3 is 3. So surface area is equal to 2. 5 and 15 is 20, plus 3 more is 23. So surface area is 46 centimeters squared. Okay, and it's centimeters squared. I didn't have to write that because it's shown up here telling me what units it is. But the reason that is because you're going the length times the width, and the length is measured in centimeters, and the width is measured in centimeters. So centimeters times centimeters give you centimeters cubed. Volume, much easier. Length times width times height. Volume equals 15 centimeters cubed. All right. So that, what's going to happen if we double everything? If we take this and make this 10, right? I'm doubling this, and make this 2, and make this 6. So what I would like you to do is, how about you pause the video and do the surface area and the volume. And actually, you can do the triple, and you can even do the half size original at the bottom here. All right, I'm going to trust that you did that. So surface area is equal to 2 LW plus LH plus WH. Surface area is equal to 2. So 10 times 2 plus 10 times 6 plus 2 times 6. I had that part right last time. Okay. 10 and 2, 2 and 6. All right, so surface area is equal to 2 times 20 plus 10 times 6 is 60 plus 2 times 6 is 12. surface area is 2 times, let's see, 20 and 60 is 80, 90, 92. So surface area, keep my handy dandy calculator, 2 times 92, 184. Squared. Now, so we're going to, I wonder if there's a relation between 184 and 46. How many 46s are there in 184? I bet there's 4. So 184 divided by 46 is 4. So this is 4 times that one. 4 times as big. Well, that's what we expected, right? We knew that from before. If you double the length, when you're doing just a plane area, and you double the width, right? So you basically you double the 2 dimensions, it ends up being 4 times as big. Well, let's see what happens with our volume. Volume is length times width times height. Volume is 10 times 2 times 6. Volume is 20 times 6, that should be 120 centimeters cubed. I don't know what that relation is. Where can I put my calculator so you guys can see? Oh, I have to go like that. That's silly. Okay, so I'm going to go 120 divide by 15, and we get 8. That's big. We'll come back to that. I'm not seeing 100% sure what that pattern is yet, but give it a shot. All right, so triple. So 5 times 3 is 15. 1 times 3, oopsies, is 3. And 3 times 3 is 9. So surface area is equal to 2. I'm just going to be lazy here. 15 times 9. That's what this one, this one, this one, this one, this one, this one. Surface area is equal to 2. 15 times 3 is 45. Plus, yeah, 15 times 9, I don't know. 135 plus 27. Surface area is equal to 45 plus 135 plus 27 is 2 times 207. Surface area times 2 is 414 centimeters squared. Yeah, I'm going to take that and I'm going to divide it by 46, and let's just see. So, from what we know from before, if we triple it, this should be, yeah, it should be 9 times as big. Divide by 46, and it is. So I'm just going to put 9x there, 9 times as big. So we're seeing a nice pattern here. Don't have enough evidence here to figure that one out. So volume is length times width times height. Volume is 15 times 3 times 9. 15 times 3 times 9 is 405. Now, let's divide that by 15 and just see what we get. Divide by 15. Oh, 27 times as big. So we got 8 times as big, 27 times as big. So what are you guys seeing? At 4x, that was 2 squared. What's 8? That's 2 cubed. Right? So when you double it, your surface area, the scale factor is 4. Hold on. Hey, we're back. Sorry about that. Bean decided to protect me from, I have no idea what she saw or what was bugging her. Anyway, so back to where we were. So if we're looking when we tripled it, that's 3 squared, so because it's 9 times as big. That's actually what we did to one side. We squared that. And the 27, you know what? That's 3 cubed. So it looks like surface area. This is always going to be k squared. And this is going to be k cubed. Ta-da! That's what you're supposed to get out of this. And just for fun, let's do it one more time and see if it works. And I'm probably going to regret this because we're going to get fractions when we go half the size of the original. So if we go half size, what should happen to our surface area? I mean, clearly it's going to be smaller. Is it going to be half size? I don't think so. It's going to be smaller than that. Let's see. So my original was 5, so this is 2.5, and 0.5, and 1.5. So surface area is equal to 2.5 times 0.5 plus 2.5 times 1.5 plus 0.5 times 1.5. So I'm just using the pattern. Surface area is equal to 2.5 times 0.5 be 1.25 plus 2.5 times 1.5, 3.75 plus 0.5 times 1.5, 0.75. Surface area is equal to 2. Now I'm going to add them up, right? Oops. I don't need to put the 2 there again, did I? 11.5. We said it was supposed to be smaller. So every other time we took this number, divided it by that, and this number and divided by that. So let's go 11.5 and divide it by 46. And, not surprising, we get 0.25 times as big, which is 1/4. I don't know if that helps you, but it's kind of like we took one side and reduced it by half. We took the other side and reduced it by half. So that everything a half times a half is 1/4. So now our volume, length times width times height, 2.5 times 0.5, 1.5. .875 centimeters cubed. This was centimeters squared. Now, let's do some predicting first. So we went half size. So it should be 1/2, which is what we did to one side, and cubed. So that's going to be, okay, I'm going to do it this way. Or you can do 0.5 times 0.5 times 0.5, 3.125. So this is my prediction. And let's see, when we go, what did we do all the time? So this number and divided it. So we went this one and divided by that. So 1.875, excuse me, divided by 15. And sure enough, oopsies, 0.125 times as big. So there you go. Now you know, anytime it's area, whether it's just a regular flat area, or whether you're 3 dimensions and using surface area, the variable is going to be it's k squared, right? Your scale factor is squared. If it's a volume, your scale factor is cubed. All right, end of the video.